find out eigenvectors of a given matrix. So first of all, I will tell about the definition of eigenvector. If you remember, earlier I explained, if A is a given matrix and lambda is called eigenvalues of the matrix A, if there exists a non-zero column vector x such that Ax is equal to lambda x, then x is called eigenvector. So remember, one question they can ask based on this for any exam, they will give lambda eigenvalues, they will give matrix, or they will give matrix and eigenvector, and they ask to find out the corresponding eigenvalue. They will give matrix and they will give eigenvector x. Then they ask you to find out lambda, means eigenvalue corresponding to that eigenvector. So just you put here A is given, x is given, A into x you usually calculate, then find out lambda into x and equate both. You will get the value of lambda. So this is the way we do one question. Now we have to find out x. So what is the property? Lambda A minus lambda into x is equal to 0 when we transform. If you know this one, then too much good. Otherwise, please see my previous lecture, which is based on eigenvalues of matrix. So here I explain the theory, how we explain it. So now, it means we have to find out solution of this. What is mean? It's very simple mean. It's mean x belongs to null space. X belongs to null space of A minus lambda. Now the question is, what is null space? For that purpose, you just wait for next lecture. In next lecture, I will explain you about row space, column space, and null space. So null space means the solution of Ax is equal to 0. Solution of Ax is equal to 0 because here A minus lambda. So we told it's a null space of A minus lambda. Null space play very important role for eigenvector, because in that way we come to know how many eigenvector exist which are linearly independent for that corresponding eigenvalues. So hope you understand this one. How many actually corresponding to one eigenvalue, we can write infinite eigenvectors, but that all not work because they are dependent. So for independent, how many exist? For that purpose, you have to know about null space. I will explain in example what is the meaning of that. So one more point you have to know: rank nullity theorem means rank A plus nullity of A is equal to dimension of matrix. You can say it's the dimension of V actually. Rank nullity theorem is very simple. Rank V plus nullity is equal to dimension of V. But that is a different part. Just you know order of matrix. What is dimension of A? What is the order of matrix? If it's a 3 cross 3 matrix, just you write 3. Then rank is still rank A. We can calculate easily. Then easily we come to know about null space. And once you know null space, just put the find out the values, and then easily you come to know how many eigenvectors we can find which are important for corresponding eigenvalues. Okay, so now I am moving for question. Means how generally we are doing. For general it's not required. For deep knowledge this required. So A always they given, you have to calculate eigenvectors. See how many eigenvalues are there, corresponding to each you have to calculate eigenvector. So if there are 3 eigenvalues, it means you have to calculate 3 eigenvectors corresponding to each one. So how we calculate eigenvalue? We write first characteristic equation. What is characteristic equation? Lambda cube minus beta is 5 plus 1 plus 1. 7 lambda square plus A11. What is A11? 5 minus 1, 4. What is A22? 1 minus 9 minus 8. What is A33? 4. So what is also 0. 0 minus determinant. What is determinant? 1 2. So 1 is 2. So what is the equation? Lambda cube minus 7 lambda square plus 30. So if you know how we relate this one, then too much good. Otherwise, please see my previous lecture. Link is available on my button. So now, what are the lambda values? When you solve, it will come lambda is minus 2, 3 and 6. You can say it's satisfied. 8. Plus so lambda is equal to minus 2 is a root. Similarly, you can go for 3 and 6. Now, once you know about the eigenvalues, now our work is done. We have 3 distinct eigenvalues. When eigenvalues are distinct, these all are useless, nothing matter. Just calculate eigenvalue vector by this way. The problem starts when we have repeated eigenvalues. So here we don't have repeated eigenvalues, so it's very simple. Eigenvector of lambda is equal to minus 1. So what is the eigenvector? A minus lambda I into x is equal to 0. Solution of this. That is x, na? Solution of this. So just put lambda value. So, what is A minus lambda I? A minus lambda I is what? Subtract lambda from diagonal. So 1 minus lambda 1 3, 1 5 minus lambda 1 3 1 1 minus lambda. So this is your A minus lambda I. So just you have to put lambda value in this. Lambda value minus 2. So what becomes A minus lambda I? 3 1 3 1 7 1 3 1. So how we solve this one? So best part is convert this one into row echelon form. How we convert? See. 3 1 3 3 1 3 it's same. So make it 0. First we change the row to 1 7 1. I will do separately. That's better. So what is that? 3 1 3 1 7 1 3 1 3. So first step is convert this one into echelon form. How we convert? First make this one 1. How? See, first we make this row 0, na? That's better. So R3 change to R3 minus R1. So 3 1 3 1 7 1. This is 0 0 0. That's very simple. Now go for this. R1 interchange with R2. What we get? 171 313 0 0 0. Again make this one 0. How we make 0? R2 change to R2 minus 3R1. What we get? 171. 0 minus 20 0 0 0. So this is the final equivalent form. What is that? 171 0 minus 20 0 0 0 0 multiplied with x y z is equal to 0 0 0. Now write in equation form x plus 7y plus z is equal to 0. And what is second equation? Minus 20y is equal to 0. So from here we can get y is equal to 0 always. So y 0 means from first x plus z is equal to 0. So to unknown one equation, how we solve? Take any one by your choice. Suppose I am taking k value 1 and what is x value? Minus. Your choice. You can take anything. You can take, don't take 0 because y already 0. If z 0 then x 0 and 0 is eigenvector. No, it's not possible. So take any non-zero value, so you can get the value x and z. So what is the eigenvector? Eigenvector is x value minus 1, y 0, z 1. This is the first eigenvector corresponding to lambda is equal to minus 1. Similarly, we can go for eigenvector for 3. Similarly, we can go for 6. See, what is the role of that which I told about null space? See, when we converted this, what is the rank of this? See, how many non-zero rows are there? 2. So what is the rank? 2. Rank is 2. So rank of A is 2. What is order of A? That is 3. So what is null space of A? So null space plus rank space is equal to dimension of B means is 3. What is null space? Null space is 3 minus 2 1. So corresponding to this we can calculate only one eigenvector that is linearly independent. So that is very important. How many eigenvectors we can calculate from this? 1. Similarly, for eigenvector for lambda is equal to 3. Lambda is equal to 3, what happened? Very simple, same thing. Lambda is equal to 3 means put lambda value 3. So 1 minus 3 minus 2, 1 3, 1 2, 1 3 1 minus 1 minus. So this is the eigenvector. Now we convert this one in echelon form. So many are not calculating in echelon form. So let them their choice. Best thing is you convert it and then do it. Just to multiply and solve it, that's also work. So many books it's given, but not always work. So it's better you will go follow this procedure. So what is the given matrix? Minus 2 1 3 1 3. We first represent R1 to R2. 1 to 1. So then R2 change to R2 plus 2R. 1 becomes 1 to 1 0. Then R3 change to R2 minus 3R 0. So divide by R3 by minus 5. So we get 1 to 1 0 1 0 and R2 by 5. 1 1 0 minus 1. Again you subtract. So R3 minus R2 1 get 1 to 1 0 1 1 0 0 0. So finally we have this matrix 1 2 1 0 1 1 0 0 0. So what is the equation? X plus 2y plus z is equal to 0 and y plus z is equal to 0. now we have to equation the unknowns, take anything of your choice. We have taken y value 1. What is z value? Minus 1. Y and z minus 1. Then what is the x value from first? Y value minus 1. So 2 minus 1. 2 minus 1 means 1. X is minus 1. What is the eigenvalue? X value minus 1, y value 1, z minus 1. So this is second eigenvalue. Similarly, we can find out for third. What is third one? Lambda is equal to 6. 6 this time. This is the best way to calculate eigenvector. Go for that one, because this is most important, because it's reliable. So lambda is equal to 6 means 1 minus 6 minus 5, 1, 3, 1, 1 minus 6, 1. Now again convert it to form and you will get the eigenvectors of the given matrix. So what is the I will check R2 to R1, that's the best way. 1 minus 1 1, minus 5 1 3, 3 1 minus 5. So how we make it? R2 check to R2 plus 5 R1 becomes 1 minus 1 1, 0 minus 1 minus 4 R2. This one R2 into R3 minus 3 R1 is 0, 4 minus 8. So divide by minus 1. So R2 is to R2 into R2 divided by minus 4 and R3 by 4. So what we get? We get 1 minus 1 1, 0 minus 4 means 1 minus 2, 0 1 minus 2. When you subtract, we get that we are get right. Final matrix is in form 1 minus 1 1, 0 1 minus 2, 0 0. Multiplied with x y z is equal to 0 0 0. So just multiply. We get these two equations, and as usual, if z value 1, we get y value 2. Z 1, y value we get 2. When we put y and z in this, we get x value. So what is the eigenvector? 1 2 1. So in this way, we calculated all three eigenvectors corresponding to three distinct eigenvalues. So when eigenvalues are distinct, then it's nothing matter. We can calculate in easy way. If you go directly for that, I will tell that one also. If we go for directly a minus lambda into x is equal to 0, second way to calculate eigenvector. So what is that? Lambda is equal to minus 2. You have to together. It is 3 1 3 1 5 minus 3 7 1 3 1. So multiplied with x y z, that is equal to 0 0 0. Then what is the equation? 3x plus y plus 3z is equal to 0. Then x plus 7y plus z is equal to 0. Control equation is same. So no need to write. Always first two equation only you can solve. How we solve? We are using a cross multiplication method to solve system of equation. So in that way, how we write? First we write x, then minus y, and then z. Then we write it determinant down. When we writing x, we close this one. Write the coefficient 1 7 3 1. 1 7. Then y 3 1 then z. One thing we can find out, what can we find? Is equal to k, like nothing, but 1 minus 21, 3 minus 2, 0. Because 0 minus 1 is there. But ratio is you can divide 0 0. 22. What is the eigenvector? In this way also we can calculate using cross multiplication method, but that is better. Why better? Because that one tells you about null space. Means how many eigenvectors we can calculate from that eigenvalue. There are infinite eigenvectors corresponding to one eigenvalue, but we can't calculate all. Maximum how many we calculate? That will tell eigenspace, because we require linearly independent eigenvectors, not dependent. So in this way, if you calculate that most of the time they are dependent. If eigenvalues are repeated, if it is distinct, you can follow any way, any rule, nothing matters. But if it is repeated, then my advice, please follow that one. Or you practice this one, this is so much easy, you can get easily. So thank you, and please subscribe the channel.